Okay, for number 30, we want to simplify, assuming all the variables are positive, right? So we don't have to worry about absolute value here. Part A, square root of 9x to the 8. I think you can handle that. It's the square root of 9 times the square root of x to the 8. Right, so square root of 9 is 3, and the square root of x to the 8 is x to the power 8 over 2, right, which is just x to the 4. So 3x to the 4. Right. The only thing you have to make sure you know here is that you're allowed to split up square roots as long as they're, positive. Right? And you can do that with any roots, right? Any nth roots, cube roots, fourth roots, and so on. Right. The other thing, of course, that's helpful here is that if you have a to the power m over n, that's just the nth root of a to the mth. That's an m. So we'll see that a lot, right? So part B, done much the same way. The cube root of 8y to the 18. So just split that up as the cube root of 8 times the cube root of y to the 18. So that's just going to be 2 times y to the 18 over 3. So 2y to the 6th. Part C, the fifth root. Boy, we don't see too many of those, but okay, here's one. Of a to the 10th over b to the 35. So this is the fifth root of a to the 10 divided by the fifth root of b to the 35. Right? And so this is just a to the 10 divided by 5 divided by b to the 35 divided by 5. So a squared over b to the 7th. And finally, part D is another square root. Square root of 81, x to the 10, y to the 4. So square root of 81, square root of x to the 10, square root of y to the 4. So that's 9, x to the 10 over 2, y to the 4 over 2. So we're just going to get 9x to the 5 times y squared. Sorry, that's a 9. 9x to the 5y squared. All right. Okay, and 31, again, these are just too easy. Don't expect these on the test, right? So this is just the cube root of x squared. Right? You can also write it as the cube root of x squared, assuming that x is positive, which it is here. Right, so y to the 3/4 is just the fourth root of y cubed. And part C is really the only tricky one. X squared plus 25 to the 1/2 is just the square root of x squared plus 25. And that's it. Right. The temptation, of course, is to write this as x plus 5, but if you do that, you're going to get it wrong. Right? You can split up a product, but you cannot split up a square root like that. When you're adding or subtracting, it just does not work. So don't make that mistake. Okay, so 32a. The easiest way to do this is to distribute the 6 first, right? Rather than try to subtract the exponents. This is x to the negative 2 raised to the power 6, y to the negative 1/2 raised to the power 6, over x to the 1/3 raised to the power 6, times y to the negative 4/3 also raised to the power 6. And by doing that, essentially all the denominators should cancel, I think. You should get x to the negative 12, y to the negative 3, over x to the 2, y to the, negative 24 divided by 3 is negative 8. Right? Now you can subtract the exponents, right? Negative 12 minus 2 is negative 14, and negative 3 minus negative 8 is 5. And don't forget, no negative exponents, so let's just bring the x to the 14 downstairs. This is y to the 5 divided by x to the 14. Okay, and then part B. Right, we're just using the same usual rules for exponents here. Right, so this is going to be x squared to the 1/4 over 16 to the 1/4 times y cubed to the 1/4. divided by y to the, well, I was going to do it all at once, y to the 3 to the 1/2 divided by 4 to the 1/2 times x to the 5 to the 1/2. Right? So everything gets a 1/2 there. Yeah, I should have, keep change flip, right? But we can do that now, right? So let's keep the first one. And while we're at it, 2 over 4 is just 1/2, right? So x to the 1/2. The 4th root of 16 is 2. And then this is y to the 3/4, right? Times, when we flip this over, 4 to the 1/2 is the square root of 4, which is 2, times x to the 5 over 2, divided by y to the 3 over 2. Okay, so far? All right, so the 2's cancel. That's nice. And we get x to the 1/2 plus 5 over 2, divided by y to the 3/4 plus 3 over 2. So that's going to be 6 over 2 for the exponent of x. And for y here, we need a common denominator. So this is going to be y to the 3 over 4 plus 6 over 4, which I think is 9 over 4. So we get x to the 6 over 2 is 3, so x cubed. And then y to the 9 over 4. So I think that's it. Okay, 33. Part A, I'm going to skip that because that's about as easy as it's going to get. So let's just do part B, which is only slightly harder. So we have the square root of 75, x to the 5, right, y to the 9. So how do we simplify that? Well, first, let's just take the 75, square root of 75 separately, square root of x to the 5, and then the square root of y to the 9. Okay, so we know 75 is 25 times 3. And we know x to the 5 is x to the 4 times x. And we know y to the 9 is y to the 8 times y. So splitting them up again, you get square root of 25 times the square root of 3, square root of x to the 4 times the square root of x, and the square root of y to the 8 times the square root of y. You see where this is going, right? Square root of 25 is 5, so 5 times the square root of 3. The square root of x to the 4th is x to the 4 over 2, but that's just 2, right? X squared, times the square root of x. And then the square root of y to the 8 is y to the 8 over 2, which is y to the 4, times the square root of y. So bring everything in front. 5x squared y to the 4th, and then the square root goes in the back, square root of 3xy. Okay, that's 33b. Okay, 34a, we want to simplify the square root of 72 times the square root of 243. And I mean, this really is just too easy for a test. But if it is on a test, here's how you should be doing it. All right, so 72 we know is 8 times 9, or 9 times 8, right? And 243, well, is 81 times 3, right? So you see where this is going. The square root of 9 is 3. The square root of 8, oh, we could go further with that, right? 8 is 4 times 2. Square root of 81 we know is 9. Times, sorry about that, times 3. Right? And so we have 3 times 2 times the square root of 2 times 9 times the square root of 3. So 3 times 2 is 6. 6 times 9 is 54. And then the square root of 2 times 3, that's just the square root of 6, right? So 54 times the square root of 6. Okay, part B, yeah, this is a little bit more reasonable because it's the 5th root, and like I say, you don't see that too often. So this is just the 5th root of 3 times a squared times a to the 4th times b to the 7 times b to the 12. So yeah, you can combine everything as well, right? So that's going to be a to the 6 times b to the 19th. All right, now we have the fifth root of 3. There's nothing you can do with that. But the fifth root of a to the 6, we can simplify that. And the fifth root of b to the 19, we can simplify that, right? So this is just the fifth root of a to the 5 times the fifth root of a to the 1. And then we have the fifth root of b to the 15 times the fifth root of b to the, so 19 minus 15 is 4. Okay, so we still have the fifth root of 3. The fifth root of a to the 5th is just a to the 5 over 5, which is just a to the 1, or just a, right? Times the fifth root of a to the 1, and 1 is less than 5, so that's simplified. The fifth root of b to the 15 is b to the 15 over 5. 15 divided by 5 is 3, times the fifth root of b to the 4. Now, 4 is less than 5, so that's considered simplified. So we have a times b cubed, and then times the fifth root of 3ab to the 4th. Okay, so that's part B. And then part C, we have the square root of 48 plus the square root of 12. Again, this should be easy, but it's not that easy, because if you're thinking square root of 60, guess again, it's not that simple, right? When you're adding, you have to add like radicals, right? So 48, we can split that up as 8 times 6, but those aren't perfect squares. How about 16 times 3, right? Plus, and then 12 is just 4 times 3. Right? So the square root of 16 is 4. We have 4 square root of 3. And then the square root of 4 is 2. So we have 2 square root of 3. These are like radicals, right? They both are multiples of the square root of 3. So 4 of those plus 2 of those is, well, 6 of them, right? So 6 square root of 3. Okay. And by the way, this is the square root of 108. Right, 36 times 3. I want to make sure I did that right. Yeah, 108. So your guess of square root of 60, if you were guessing that, you were way off. It's not the square root of 60. It's the square root of 108. So, yep. So yeah, you cannot just add the 48 plus the 12. It would be nice, but it doesn't work that way, right? And, don't write it as the square root of 108 because that's not simplified. You want to write it 6 square root of 3 is the most simplified answer here. Okay, right. And then for part D, it looks like we have, 34D, right? So we want to simplify 2 square root of x plus 5 squared. Right. You've done this a million times, right? Just make sure you don't square them both. I know that's very tempting, and I know a lot of you have made that mistake. Right? We've all made that mistake, right? But don't do it again, right? Foil this out. We have 4 times the square root of x squared plus 2 times 5 times the square root of x. That's 10 square root of x. And the inside is also 10 square root of x. And then 5 times 5 is 25, right? So you're going to get 4x. Oops, that's an x, right? So square root of x squared is just x, plus 20 times the square root of x, plus 25, right? So, yep, if all you did was square the first term and square the last term, great, but you're missing the middle term here, which is not unimportant, right? It has to be included. All right, and finally part E. Okay, and part E is probably the most difficult one, as it usually is. But it's not that bad. After all, the first term here, there's nothing we can do to simplify it because 2 is less than 3. So I'm just going to copy it down. For the second term, we can split this up, right? This is the cube root of 8 times the cube root of x to the 4th, which is the cube root of x to the 3, times the cube root of x to the 1, times the cube root of y to the 3. And we could do that with the last term too, the cube root of 64 times the cube root of, let's see, x to the 5. Okay, so that's x to the 3, and then there's 2 left over, right? And then the cube root of y cubed, right? Okay, so cube root of 8 is 2, right? Cube root of x cubed is just x. And then we just have the cube root of x, and then the cube root of y cubed is y. Cube root of 64 is 4. Cube root of x cubed is x. And cube root of x squared is the cube root of x squared. And the cube root of y cubed is y. So it looks like we have 2xy cube root of x, not plus, but minus, right? 2xy cube root of x plus 4xy cube root of x squared. And it looks like, well, these two just add up to 0. So it's really just this last term here. Boy, I didn't think it was that simple. Oh, it's not. Oh, okay. My bad. I messed up the third line here. You see, this is x squared. I dropped the squared. So that's a squared and that's a squared. All right. All right. Well, see, I mess up too. It's not that hard to mess up here, right? Okay, so that's the first term and the last term. Those look the same, right? So 2 plus 4 is 6, so 6xy times the cube root of x squared. And then minus 2xy times the cube root of x. Those are not like terms. So I think that's as far as we can go. So I wrote it both ways. You can also factor out, right, the 2xy, right, leaving you with 3 times the cube root of x squared minus the cube root of x. So either way is fine. I would just leave it like this, the first one. All right, so again, that was the hard one. And yep, I almost messed this up because I kind of just forgot to write the 2 there for the exponent. Better late than never. Right, number 35, we want to rationalize the denominator. Right, so nothing new here. So 35a, we have 21 over the square root of 7. So you know the trick by now. Just multiply top and bottom by square root of 7. Right, again, the same denominator, right? So you get 21 square root of 7 in the numerator, and then the square root of 7 times 7 is 49. Right. However, the square root of 49 is 7, right? So that rationalized the denominator. There's no more square roots in the denominator. But there's one more thing we could do here. 21 divided by 7 is 3. So this is 3 square root of 7. Right. For part B, we have the square root of 8a over 3b. Right. I mean, one thing you could do, of course, is split this up as the square root of 8a over the square root of 3b. So just do the same trick here. I'll use a different color again. Right, multiply numerator and denominator by the square root of 3b. And if you do that, the numerator is the square root of 24ab. The denominator is the square root of 3b squared, but that cancels the square root, so it's just 3b. Okay, and then for, oh, wait a minute. I don't think 24, yep, I think we can simplify further, right? Remember, 24 is 6 times 4. So square root of 4 is 2 here, right? So, yep, this is going to be 2 times the square root of 6ab over 3b. Nothing cancels, but yeah, you should simplify the numerator. The square root of 24 is not considered simplified. Phew. All right, good. And then part C. Okay, yep, this is going to be the hard one. 4 plus square root of 3 over 6 plus square root of 3, right? The technique here is not to multiply by square root of 3, right? We tried that, it doesn't work. And it's not to multiply by the same denominator, 6 plus square root of 3. That's also not going to work. You have to multiply by the conjugate, 6 minus the square root of 3. That's the only thing that'll end up canceling all the square roots in the denominator. So for the numerator, what do we get? We get 24, right? 4 times 6. And then minus 4 square root of 3 plus 6 square root of 3 minus the square root of 9. And then for the denominator, we get, well, 6 times 6, right? 36. Minus 6 square root of 3 plus 6 square root of 3 minus the square root of 9. Okay, so 24. And then these are like terms, right? Negative 4 plus 6 is 2, so 2 square root of 3. And then the square root of 9 is just 3. In the denominator, we have 36. Negative 6 square root of 3 plus 6 square root of 3 is 0. And then the square root of 9 is 3. So we get 24 minus 3 is 21 plus 2 square root of 3 divided by 36 minus 3 is 33. And I think that's as far as we can go here. Right. All right, now we're solving equations with square roots or cube roots, but usually square roots. So the first one, part A, square root of 4x plus 1 minus 4 equals 0. Now, some of you have been very sloppy about this, and some of you have just been doing this, essentially extending the square root over the negative 4, but it's not there. You cannot do that. Okay, so be very careful of that. In fact, the whole point here is that because the negative 4 is not under the square root, we can do the opposite. We can add that to both sides. So the square root of 4x plus 1 is equal to 4. Right? Now to get rid of the square root, you just square both sides. So on the left, we're left with 4x plus 1. And on the right, 4 times 4 is 16. So at this point, you just take away the 1 and divide by 4. Right? So you're going to get x equals 15 over 4. All right. And part B, not much trickier. It's the cube root of 2x minus 5 equals 3. So there's nothing to add or subtract here, right? You can't split this up as 2 separate cube roots. But I don't know why you'd want to. Just to get rid of the cube root, just raise both sides to the power 3. So 2x minus 5 is equal to 3 times 3 times 3, 27. Okay. Add the 5 to both sides, and you get 2x equals 32. Divide by 2. You get x equals 16. So, yep, for part B, x is 16, as you can check. Okay, part C, we want to solve for x again. 2 plus the square root of 3x minus 8 equals 0. Right. So it should be clear by now that the 2, there's no square root of 2 here, right? So I'm free to just subtract that from both sides. So I have the square root of 3x minus 8 on the left, and I have negative 2 on the right. All right, so now let's get rid of the square root. So we do that just by squaring everything. Square the left side, square the right side. You get 3x minus 8 is equal to negative 2 times negative 2. That's positive 4. Right. Add the 8 to both sides, and you get 3x is equal to 12. Divide by 3, x is 4. Okay. And I'll leave it to you to check. Actually, I think I'm going to check as well, right? So 2 plus the square root of 3 times 4 plus 8. Does that equal 0? No, of course not. We're adding two positive numbers here, right? You're not going to get 0. So 3 times 4 is 12. And 12, oh, I'm sorry, it's 12 minus 8, not 12 plus 8. Yeah. Okay, yep, so 12, I'll color, minus 8. So 12 minus 8 is 4, and the square root of 4 is 2, and 2 plus 2 is definitely not 0. Right? So yeah, so x equals 4 is wrong. So what did I do wrong? Well, nothing, not really. I didn't make any mistakes here. This is just an extraneous solution, right? So there is no solution here. That's the answer. And the only way you'd really know that is if you checked here. Okay. On the other hand, if you were clever, if you looked at this step right here, you would notice something very wrong, because the left side is a square root. A square root is always positive, right? On the other hand, the right side is a negative number. You cannot have a positive number equaling a negative number, right? Positive 2 does not equal negative 2. So essentially this was doomed from the start. There is no value of x that will ever make this square root a negative 2, right? The left side can never be negative 2 here, right? It's going to be a positive number, right? So you replace x with a number, this will always be a positive. It can never equal negative 2, so there is no such value of x. That's why there's no solution. So if you go through the steps here, this is fine, but make sure you check your answer, because the 4 that we got was wrong. It's called an extraneous solution. And we've seen these before, right? Typically when you have equations with fractions or square roots, this can happen. All right, and part D, this one's actually easy. There's nothing tricky about this. Right, you just get rid of the cube root by cubing both sides. And since the cube root is on both sides, you get rid of the cube root on both sides, right? So this is just 2x minus 8 equals 5x plus 7. So take away the 5x, add the 8. You're going to get negative 3x equals 15. So divide by negative 3. X is negative 5. Okay. But let's check. I mean, it's not the fact that x is negative. That's right. I mean, that might be suspicious, because remember, you don't want to take square roots of negative numbers, at least not yet. So the square root of 2 times 5 minus 8, I'm sorry, the cube root of 2 times 5 minus 8 is supposed to equal the cube root of 5 times negative 5 plus 7. So is that correct? Well, we get the cube root of 10 minus 8. Oh, I'm sorry, negative 5. So negative 10 minus 8, which is negative 18. I think that's right. And then the cube root of negative 25 plus 7. Well, that's also negative 18. So whatever the cube root of negative 18 is, it's the same number on both sides, right? And it is a real number. It's not imaginary, right? Don't get confused with the square root of negative 18, right? That is an imaginary number, right? That is 3i squared of 2. But there's nothing wrong with taking the cube root of a negative number. It's just a negative number. Okay, so the negative 5 is correct, right? X equals negative 5 is the correct solution. Okay, so for 37, I mean, part A, you can do that. That should be easy. Part B, it's only a little bit trickier, because we have to subtract 36 from both sides. Right? So u squared is equal to negative 36, And then, because it's the square root method, we'll just take the square root of both sides. Don't forget the plus or minus. So u is going to be plus or minus the square root of 36 times the square root of negative 1. And remember, the square root of 36 is 6. The square root of negative 1 is the letter I for imaginary. Right? So u is either positive 6i or negative 6i. And you can write it all at once. Right? Okay, so for part C, y minus 2 squared is equal to 12. So using the square root method, I'm just going to take the square root of both sides, plus or minus the square root of 12. So y minus 2 is going to be plus or minus, we can simplify this, right? 12 is 4 times 3. So the square root of 4 is 2. And now just add the 2 to both sides. So 2 plus or minus 2 square root of 3. And you can leave it like that. Right? And then finally part D, okay, I'll do that as well. Okay, 2x minus 10, the quantity squared plus 4 equals 0. Again, using the square root method, we're not going to multiply this out, right? I'm just going to take away 4 from both sides. And we got 2x minus 10 squared equals negative 4. So to get rid of this square, we do the inverse. Take the square root. Don't forget the plus or minus. So this is 2x minus 10 is equal to plus or minus the square root of 4 times the square root of negative 1. So that's just going to be 2i, plus or minus 2i. So at this point, we're going to add 10 to both sides. Remember, we're solving for x here. So we're going to have 2x plus 0 equals 10 plus or minus 2i. Now just divide by 2. So x is going to be 5 plus or minus I. Right. Again, you can write them separately, 5 plus I, 5 minus I. That's okay too. But yeah, 5 plus or minus I is okay in this case. All right, number 38a, we want to solve the equation w squared minus 8w minus 4 equals 0 by completing the square. Those are the directions. If you want to use some other method, I'm not going to stop you, but you're not going to get credit, right? You have to use the method that they want you to use, in this case, completing the square. Right? So you might want to use the quadratic formula. Some of you did that, and then you wondered, why did I lose points, even though I got it right? Because you didn't follow the directions. Okay, so read the directions carefully. So remember what completing the square involves. Right? This is already in standard form. A is already 1, so we don't have to divide by anything. What we want to do is add the 4 to both sides, right? And when we do that, it's true that this is no longer in standard form. However, when you're completing the square, that's okay. So now I take the number negative 8, that's the one in front of the w here, right? And I do two things. I divide by 2 and I square it. So negative 8 divided by 2 is negative 4, and negative 4 squared is 16. So what am I going to do with the 16? Add that to both sides. Oops. Right, so w squared minus 8w plus 16 is equal to 20. So the whole point for doing this is that now we can factor this. Right? This factors as w minus 4 times w minus 4, or better yet, w minus 4 squared. So now I can just use the square root method, right? Take the square root of both sides. Don't forget the plus or minus. So w minus 4 is going to be plus or minus 20, but remember, 20 is 4 times 5. And the square root of 4 is 2. So w minus 4 is plus or minus 2 square root of 5. I'm going to add the 4 to both sides. So w is just 4 plus or minus 2 square root of 5. And again, you can leave it like that. Okay, so that's 38a. And I guess I'll do part B as well. It's done much the same way. The first step is to write the equation in standard form. And luckily, they do that for us. If it's not, then you got to add everything, get 0 on the right. Right? And then if a is not 1, we divide by a, but a is 1, so there's no point in doing anything there. Now we just take away the 52 from both sides. So we're going to get x squared plus 12x equals negative 52. Right? And leave some space here because we know we're going to add something here. What are we going to add? Well, take the number in front of the x, right? That's the 12. Divide it by 2, and then square it. So 12 divided by 2 is 6. 6 squared is 36. So I'm just going to add 36 to the left side. But to balance the equation, I have to add 36 to the right side. So x squared plus 12x plus 36, which is a perfect square trinomial, is equal to negative 52 plus 36, which I think is negative 16. Yep. Right, so the left side factors as x plus 6 times x plus 6, or x plus 6 squared. So to undo the square, we take the square root. So x plus 6 is equal to plus or minus the square root of negative 16 is, right, 4i. And then just subtract the 6 from both sides. So x is going to be negative 6 plus or minus, so let's try that again, negative 6 plus or minus 4i. And you can leave it like that, or you can split them up, negative 6 plus 4i, negative 6 minus 4i. And again, I like doing that because I want to emphasize that, right, even though this is one statement here, there's really two separate solutions here. When you solve a quadratic equation, typically you do get two solutions. Right? You could get one in some rare cases, but you do get at least one and sometimes two. Right? They may not be real numbers. These are imaginary numbers. These are complex numbers, but they can be solutions of quadratic equations. All right, moving on to 39. Here we want to solve x squared plus 5x equals 3, but now we're not going to complete the square. We're just going to use the quadratic formula. Now, of course, you have to know the quadratic formula, right? This is not the quadratic formula, right? This is the quadratic equation that you're solving in standard form, right? So the quadratic formula is what you get when you solve for x. And the solutions are negative b plus or minus the square root of b squared minus 4ac all over 2a. You can sing it if you want. I'm not going to do that, just as long as you remember it. And we're just going to plug in a, b, and c. So what is a, b, and c? Well, first of all, notice that this equation is not in standard form. We have to subtract 3 first, right? We have to get everything on the left, leaving 0 on the right. So now we know a is 1, right? B is 5, and c is negative 3. So plugging those numbers into the formula, you just get negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 3 all over 2 times 1. Okay, and those are the solutions. We just have to simplify, as always. So negative 5 plus or minus the square root of 5 squared is 25. And negative 4 times negative 3 is positive 12. And 2 times 1 is 2, right? So this is negative 5 plus or minus the square root of 25 plus 12 is 37. over 2. And that's it. Those are the solutions, right? There's two of them, one corresponding to a plus, one corresponding to a minus. But if you want to write them all at once, that's fine. Right, 39b. Okay, 2x squared equals 8x minus 20. Again, not in standard form, so let me drag the 8x to the left. Negative 8x plus 20 equals 0. So a is 2, b is negative 8, c is 20. On the other hand, they're all divisible by 2, so why don't we just divide everything by 2? You don't have to, but why not? Makes it easier. So I'm just going to use a is 1, b is negative 4, and c is 10. Plug those into the quadratic formula, and you'll get x equals negative 4 plus or minus the square root of negative 4 squared, minus 4 times 1 times 10, all over 2 times 1. So you're going to end up with positive 4 plus or minus the square root of 16 minus 40 over 2. And 16 minus 40, right, so 4 plus or minus the square root of, I think, negative 24 over 2. So because you're taking the square root of a negative number, this is going to be I times the square root of positive 24. But I think we can simplify that, right? So leave the I in front. And then we have the square root of 4 times the square root of 6. Right? But the square root of 4 is 2. So you're going to have 4 plus or minus 2i squared of 6 over 2. And you might as well just divide them both by 2. So 2 plus or minus I squared of 6. Right. Right. So that's part B. Part C. Again, we want to solve 1/8 x squared plus x equals 5 over 2. All right, so first of all, it's not in standard form. If you're going to use the quadratic formula, you better subtract the 5 over 2 from both sides. So we have 1 over 8 x squared plus x minus 5 over 2 equals 0. And just to remind you, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, very good if you know that. So what numbers am I plugging in here? I can plug in a is 1 over 8, b is 1, and c is negative 5 over 2. I don't want to do that. I hope you don't want to do that because nobody likes fractions, right? So forget that. You remember what to do. Multiply by the least common denominator, in this case 8. So multiply both sides by 8, and you're going to get 8 over 8 x squared plus 8x minus 5 times 8 over 2. And 0 times 8 is still 0. So 5 times 8 over 2 is 40 over 2, which is 20. So this is just x squared plus 8x minus 20 equals 0. Now, no issue, right? A is 1, B is 8, and C is negative 20. Plug those numbers into the formula. So negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 20, all under the square root, divided by 2 times 1. All right, so negative 8 plus or minus the square root of 64 plus 80 over 2. Okay, so negative 8 plus or minus the square root of 64 plus 80 is 144 all over 2. The square root of 144 is exactly 12. So this is just going to be, well, negative 8 over 2 plus or minus 12 over 2. So negative 4 plus or minus 6. Now, in this case, you cannot leave it like this. If you leave it like this, you're going to lose some credit here. You're going to lose some points, right? because you can split this into two numbers, right? Negative 4 plus 6 and negative 4 minus 6. Negative 4 plus 6 is 2. Negative 4 minus 6 is negative 10. So the answers, the solutions to this equation are nice numbers, right? Oh, I messed up the equation. Let me write it down again. Sorry, not the solution, the equation. The equation was 1 over 8 x squared plus x equals 5 over 2. So even though the equation looked horrible with all these fractions, the solutions are nice and simple. X equals 2 and x equals negative 10. As you can check, right? Plug those in and you'll see that they work. All right. So when you get nice whole numbers like this, because the square root of 144 was a perfect square, right? It's not imaginary, it's not irrational. You can simplify in this way. Okay, and finally 39D. Again, we want to solve this by using the quadratic formula. And it's already in standard form. A is 3, B is 8, C is negative 2, and it equals 0. So plugging these numbers in, you just get negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 2, all over 2 times 3. Again, just simplifying, oops, sorry, it's supposed to be negative 8 plus or minus the square root of 64 plus 24 all over 6. So negative 8 plus or minus the square root of 6, 7, 8, so 88 all over 6. I think we can simplify that, right? 88 is 4 times 22. Right, so we're going to get the square root of 4, which is 2. So negative 8 plus or minus 2 square root of 22 over 6. So negative 8 over 6 plus or minus 2 square root of 22 over 6. Actually, we don't have to split this up because I'm just going to, well, you could, but you can also, right, you're just dividing both by 2 here. So if I factor out a 2 from the numerator, I get negative 4 plus or minus the square root of 22, and then divided by 2 times 3. Right, the 2's cancel. So x is just going to be negative 4 plus or minus the square root of 22 over 3. Right, because these are irrational numbers, you're allowed to leave it with the plus or minus in this case. Okay, so we'll go on to number 40 and 41, and then we'll be done. Okay, so for number 40, we want to find the exact distance between the 2 points 5, 9 and negative 1, 5. Okay, so think about what we're doing here, right? We're given 2 points, x1, y1, and x2, y2. If it helps, let's just write those down, right? So for x1 is equal to 5, y1 is equal to 9, x2 is negative 1, and, oops, sorry, y2 is also 5. So don't get those mixed up. And remember, we're looking for distance. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, you should know that, right? It's the formula for distance. So just plugging in the numbers now, we're going to get the square root of negative 1 minus 5 squared plus 5 minus 9 squared. So negative 1 minus 5 is negative 6. 5 minus 9 is negative 4. But negative 6 times negative 6 is positive 36. And negative 4 times negative 4 is positive 16. Right? So there's nothing negative here. Right? There's nothing negative under the square root. Even though you get a negative number here, by squaring it, you change it to a positive. Right? It's a negative times a negative. And then 36 plus 16 is 52. And the square root of 52 is, well, square root of 4 times the square root of 13. So 2 times the square root of 13. Right. I mean, yes, it's approximately, I don't know, 7 point something. But we're not looking to approximate. We want the exact distance, right? So you want to simplify it. Yes, be careful you don't split up the square root again. I know it's very tempting to do square root of 36 plus the square root of 16. That would just be 6 plus 4 is 10, but 10 is the wrong answer. So yes, you're not allowed to do that when you're adding or subtracting. Right? You can do it if you're multiplying or dividing, but not when you're adding or subtracting. We've seen that many times already, right? Okay, and then finally number 41. We want to find the midpoint. I'm just going to copy it down here. Between the points 2, -5 and -14, 8. Okay, so again, we're just given 2 points, right? x1, y1, and x2, y2. So let's write those down. x1 is 2. Y1 is -5. x2 is -14. And y2 is 8. Okay. Midpoints. It's the point halfway in between. When you think halfway in between, just divide by 2. Right? So x1 plus x2 over 2, y1 plus y2 over 2. Okay. You're not subtracting, you're adding here, right? So in this case, it's going to be 2 plus -14 divided by 2. And then the y-coordinate will be -5 plus 8 divided by 2. So 2 minus 14 is -12 over 2. And then -5 plus 8 is +3 over 2. So -12 over 2 is just -6. And then you can leave it as 3 over 2. Now, if you prefer decimals, okay, -6 and 1.5. Right. I'm not picky about that. Either way is fine. Just be aware that you can only do that because it's a terminating decimal. If it's a repeating or non-terminating decimal, then leave it as a fraction. Okay, so that's it. So that's my review for the tests. I hope this helps, at least a little bit. Yeah, and again, if you still want more practice, there's plenty in the old homework. You can do old homework and review those as well. But this should do it. So best of luck on the final, and I hope it all goes well.